day 7 notes. Two-way frequency tables. Another powerful way of organizing data is to create a two-way frequency table. A two-way table works when there are two different categories of data. One category is represented by the rows and the other by the columns, kind of like a times table. Entries in the total row and total column are called marginal frequencies. A way to remember this is that the margins of a page are around the perimeter of the page, and marginal frequencies are around the edge of the table, on the margins. Entries in the body of a table are called joint frequencies. A way to remember this is that these values are shared by a column and a row, so they are jointly used by both categories. Below are examples of two-way frequency tables. So, on one part you have males and females, and then you have the other one, their favorite color, red, green, blue, yellow. Those are your joint values in the middle. And then on the outside, your marginal values. Okay? iPod, no smartphone. Or smartphone, no smartphone. iPod, no iPod. Different categories on the outside. Now, let us look at an example. A group of 50 students were asked about iPod and smartphone ownership. 28 owned an iPod, and 38 owned a smartphone, and 20 owned both. So, the number of students surveyed represents the sample space, and so is the total of both the row and the column. 50, right there. The total, in other words. The other values can be entered in their location. From these tables, we can begin to fill in the rest of the table. So, if we had, just looking here, we had 28 total iPods, and 20 people had a smartphone. That means 8 had no smartphone. Now you can go any way you want. If this total is 50 and 28 had iPods, that means 50 minus 28 is 22. Right there. Also, if there are 38 total smartphones and 20 iPods, subtract and you get 18. Now again, you can work down. 22 minus 18 is 4. Right there. And then going across, 8 plus 4 is 12. There you go. That's how you fill in your numbers. And you could have gone in any order you wanted to. All right. Basic probabilities in a two-way frequency table. From the two-way table, many basic probabilities can be calculated. The marginal values provide us the probabilities of each event occurring, and in some cases they're complements. So, the basic probabilities of an iPod. Well, you look at the total for iPod and the total overall. 28 out of 50. For a smartphone, probability of a smartphone. Well, what is the total number for a smartphone? 38 out of 50. Not iPod. Again, look at your total. The total people that have no iPod is 22. Again, out of 50. And the not smartphone, right there, your total, 12 out of 50. Now, the intersection, and, in two-way frequency tables. The intersection is found at the intersection of the row and the column, just like on a multiplication table. Thus, the probability of a smartphone and an iPod is found at the intersection of smartphone and iPod. So the probability of a smartphone and iPod is 20 out of 50. The probability of no smartphone and no iPod is 4 out of 50. The probability of no smartphone and an iPod is 8 out of 50. Now, the OR. The union is not as easy to find in a two-way table as the intersection. Many students think that the probability of a smartphone or iPod is simply the addition of smartphone and iPod. This is not correct, because the intersection value gets double counted, and you can't do that. So notice, the probability of a smartphone or iPod. If you just said, I'm going to look at smartphone, iPod, and add those together, you would end up with 76. Okay? Sorry, 66. You end up with 66 total if you did it that way. But, look at this. 38 is 18 plus 20. And 28 is 8 plus 20. So we're ending up counting the 20 twice. So we're over by 20, which gives us 46. Which is why, if you look at the original green, all you're doing is adding the 18, the 20 once, and the 8, which is 46 out of 50. Because think about it. Can you actually have 66 out of 50? It doesn't make sense. But I want you to see there's two ways to think about it. Two totals take away one of the doubles, or just add up everything individually. So, no smartphone, no iPod. Again, if we did 12 and 22, we would get 44, which we don't want to do. That's too much. Again, I'm adding an extra 10 for everything for some reason. So 22 and 12 are 34, not 44. Now, what's being double counted that way? If I go this way and this way, I'm double counting that 4. So I would have to subtract that. That's one way of looking at it. Or, again, if I just look at the green, because I have my no iPod here, my no iPod, and my no smartphone. But I don't want to double count the 4 there. So there's two different ways of looking at it. And last bit of notes. Conditional probabilities and two-way frequency tables. The phrase, given that, which we just talked about on the previous day's notes, given that alters the sample space. Given that, this should be in quotes here, narrows down the total number of outcomes to a single row of column. So, conditional probabilities. Probability of a smartphone given iPod. Well, notice, if we're given that it's an iPod, that means we're removing anybody with no iPod. We're only talking about the people that have iPods, which means our total just went from 50 down to 50 minus 22, which is 28. We're not even considering the no iPods. So our total just changed, which means our denominator is going to change. So, who has a smartphone? 20. But we're not talking about 20 out of 50 because we're only looking at the iPod people. And who has no smartphone given an iPod? 8 out of 28. And we can go the other way too. We can go sideways. iPod given no smartphone. So again, we're not looking at these 38 people. So 50 minus 38 leaves us with just 12. That's our new denominator. So who has an iPod? 8 out of 12. Who does not have an iPod? 4 out of 12. So if it helps to cross out what we're not looking at also, you can do that.